All right, so here we're going to talk about limits. And today we introduced the concept of a limit. We've got two limit questions here. The first one, the limit as x approaches 2 of x squared, and then the limit as x approaches 2 of 3x minus 6. Now here, what we're asking you is, or the limit statement is asking you, as x gets closer and closer to 2 from both the left and the right side, what do the function values of x squared get closer and closer to? We don't care what happens at 2, because we never reach 2. It's just what's happening as we get closer and closer to 2. So we can see here that as we get closer to 2 from the left and from the right side, our function values are getting closer and closer to 4. So we would say that that limit is 4. Here for our linear function, as we get closer and closer to 2 from the left and the right, you can see our function values are getting closer and closer to 0, right? Because this is our x-intercept, so that is when y equals 0. So those are pretty easy to see on our graph. Now, if we look at something like this, a much more complex graph than just a straight parabola or linear function. Notice if we were to substitute 2 in the numerator, right, we'd have 4 minus 2, which is 0, and in the denominator 4 minus 12 plus 8, that would also be 0. So anytime we end up with 0 divided by 0, as we talked about today, we call that indeterminate, which means we cannot determine what the limit is without doing further exploration. Let's look at this on a graph. So here is the function. We're using parentheses so that we get an accurate graph. When I hit graph, you see it coming across. And notice, so we do have an asymptote. It doesn't show up on a graph, but notice this open space here, okay? And the reason for that is because at 2, as we get closer to 2 from the left and the right, our y values are approaching some function value, but as we noted earlier, 0 over 0 is indeterminate. So part of this is the denominator is 0, which means that the function is undefined at 2. But because we have a 0 divided by 0, one of the things we learned back in Algebra 2 in pre-calculus was that this told us that the graph had a hole in it. So that is where the hole would exist. Just a side note, if we end up with a non-zero number in the numerator divided by 0, that would be an asymptote, which is what we would have here. Let's just take a look at the table. And notice here, I've set this up already. So here we are at about 1.5, and here our y value is -1. And notice our x values by 0.05 are getting closer and closer to 2. And there's our y values, right? They're getting smaller and smaller. And notice when we get to 2, there's an error message. So not long before that, we were at 1.439. On the other side, as we get closer and closer to 2 from the right, here's our y values. You can see they're getting closer and closer. Whoops, let's get down over here. And again, an error message. So notice at 1.95, we're at -1.439. And at 2.05, we're at -1.564. So it appears, at least, both from looking at the graph and our tabular values, that this is getting closer to -1.5. All right, so how do we do this? So we haven't yet learned about limit laws. You'll get there in another day or so. So what we have learned is that we do some algebraic manipulation. So that means here we would do factoring. And so the numerator factors to x minus 2 and x plus 1, and the denominator factors to x minus 2 and x minus 4. So again, there's that factor in common. And that tells us again that we're going to have a hole at whatever makes that factor 0, which in fact is 2. So those divide out, and we're left with the limit as x approaches 2 of x plus 1 over x minus 4. So now we no longer end up with 0 over 0, and again you'll learn more about limit laws, but for now we can substitute in for the 2 for the x. In the numerator we get 3, denominator we get negative 2, and sure enough there's that negative 1.5 we saw both on the graph and through our table of values. So that's one way to do some algebraic manipulation. Let's look at a couple of others, a couple of problems that we actually saw on our AS Algebra 2 review sheet. So here we have an absolute value, and we're asking for 3 different statements. The limit as x approaches 3 from the left or the negative side, 3 from the right or positive side, and then as x approaches 3. Now, as we've talked about, anytime you see an absolute value in your function, you need to write that as a piecewise function. So that means that this is going to be x minus 3 over x minus 3 for all values greater than 3. Right? If I substitute 3, I get 0, but anything greater than 3, the absolute value is positive, so we don't need absolute value. If we were to substitute a number less than 3, like 2, that would be negative. So the absolute value makes it positive, and the other way to do that is to say we take the opposite of x minus 3 over x minus 3. And notice again, we're not including 3 here. We normally would with our absolute value, but because of our denominator, 3 makes that 0. So that would be undefined at 3. So simplifying this a little bit more, right? X minus 3 divided by x minus 3 is 1. The opposite of x minus 3 divided by x minus 3, those divide out. That's 1, and we're left with negative 1. So graphically, if we were to look at this, right, there's 3. So for all values greater than 3, it's 1. So an open circle there. And all values less than 3, it's negative 1. So there's the graph. So notice as we get closer to 3 from the left, the y values, they're constant, but that is negative 1. So back up top, we would say that's negative 1. Here, as we get closer and closer to 3 from the right side, the y values don't change. And again, we're not worried about what happens at 3. So that's positive 1. And so again, because what we've learned today, if the limit from the left does not equal the limit from the right, then the limit does not exist because they need to be the same. So we say that does not exist. Let's look at one more example where we're asked to graph a piecewise function. Again, this is also from our AS Algebra 2 review sheet. So here h of x is a piecewise function divided up into 3 pieces. It's a linear function, 2x plus 3 for values less than 0. So that would be a y-intercept of 3, but an open circle because we're not including 0 there. And there's our line. It is the parabola x squared from 0 to 2 inclusive. So 0 squared is 0, 2 squared is 4, 1 squared is 1. So there's our parabola curve between 0 and 2. And then it's the constant 4 for values greater than 2. So there's the graph of this piecewise function h of x. So the first question here is, what is the limit as x approaches 0? Well, from the left, our line y values, as x gets closer and closer to 0, our y values are getting closer and closer to 3. From the right side, as we get closer and closer to 0 from the right, our y values are getting closer and closer to 0. Well, 3 does not equal 0, so we would say that does not exist. And the last part of question here is x gets closer and closer to 2. From the left side, here we are getting closer and closer to 2 from the left. The y values are getting closer and closer to 4. And as we get closer and closer to 2 from the right side, our y values also get closer and closer to 4. So that has a limit of 4. So hopefully that helps you out, getting some of your homework questions done and fills in some gaps. If not, you can ask more questions tomorrow.